Okay, let's talk about molecular formulas and then formulas of hydrates in this video. Uh, we're going to have to remember about empirical formulas. Just keep remembering this is the smallest whole number ratio formula for a compound, and you'll be good. Okay, empirical formula is going to help us get to molecular formula. So uh, some of this might come as a wee bit of review. But first, let's talk about molecular formulas kind of in general. Okay. Let's look at some examples. So empirical formula is the lowest whole number ratio. That makes sense. Benzene, acetylene, and styrene all have the same empirical formula, CH. Um, Hopefully it makes sense that benzene, acetylene, and styrene are not exactly the same compound. So if we look at what their molecular formulas are, benzene has a molecular formula of C6H6. Acetylene has an empirical formula of C2H2. And styrene has an empirical formula of C8H8. Okay, so what do all of these things have to do with each other? How is the empirical formula related to the molecular formula? If you look at it, if we take CH and multiply it by 6, we're going to get C6H6. We take it, multiply by 2, we're going to get C2H2. And if we multiply by 8, we're going to get C8H8. Okay, so what we can conclude out of this, and this is going to be true for everything, is that the molecular formula is a whole number multiple of the empirical formula. Okay, what we'll need to do in order to figure this out, our goal is if we know the empirical formula, we should be able to work our way to the molecular formula. What we need to know is the molar mass, and we're going to have to calculate something known as the empirical formula mass. Okay, this is the molar mass of the empirical formula. Okay, um, there we go. So let's work an example. This will also help us refresh on uh, empirical formulas as we do it. All right, so we have a compound. Presumably this is something we made in the lab. We sent it off to be analyzed, and we've gotten some data back. When we do this, we have found out the mass percent of everything in the compound, right? So mass percent, mass percent, there we go. We know what CH and N, we know what the masses are, and we splurged, paid a little bit extra, and had them figure out what the molar mass of our compound is. Okay, this is what we're going to need to figure out the molecular formula. Okay, so the first step of this is we got to find the empirical formula. Okay, and we already know how to do that, right? We have percentages, so that's going to be take our percents, turn it to grams, take our grams, turn it to moles, take our moles, and turn it into a formula. Okay, so here we go. For carbon, 63.11 grams. Remember, the grams can be equal to the percent because we're assuming 100 grams total, right? So 1 mole of carbon is 12.011 grams. There we go. I'm gonna have to have room to do this. Okay. Hydrogen is 12.36 grams, and 1 mole of hydrogen is 1.008 grams. Okay. I'll go ahead and do those, write them down, and we'll do the nitrogen in a second here. 63.11 divided by 12.011 is 5.254. Moles of carbon. 12.36 divided by 1.008 is 12.2619 moles of hydrogen. And then we still got to do nitrogen. So 24.53 grams of nitrogen. We know 1 mole of nitrogen is 14.007 grams. So this is 24.53 divided by 14.007 to give us 1.75127 moles of nitrogen. Do you hear this? Um, yeah. Okay, so we have moles. To get the moles to a formula, we need a ratio, and I hope we remember that we can divide by the smallest to get that ratio. We have 5, 12, and 1. So this is our smallest, which means the nitrogen. For 4 significant figures, quit touching stuff, Chuck. Um, for 4 significant figures, our nitrogen is 1.000. Okay. Both of these will get divided by the nitrogen moles. So 5127 moles, 1.75127 moles. That'll give us carbon and hydrogen, and then we'll have an empirical formula. All right, so what do we got here? Carbon moles divided by nitrogen moles is, oh, that's nice, 3.000. That's carbon. And then for hydrogen, we'll take our hydrogen moles and divide it by our nitrogen moles. And that gives us, let's see, for 4 significant figures again, 7.002. All right, so we can conclude for this problem that our empirical formula is C3H7N. Okay, remember carbon first, then hydrogen, then everything else in alphabetical order. Remember, this is empirical formula. Okay, now we need to turn our empirical formula into a molecular formula. So let's do that. I need more room. Okay, so empirical formula C3H7N. Okay. Um, with this, we'll need to figure out our, we'll call this number 2, empirical formula mass. Okay. It's just like we would calculate the molar mass, but we're going to calculate the molar mass of the empirical formula. Okay. So 3 times carbon, 12.011. Meow. Sorry. 7 times hydrogen, which is 1.008. And 1 times nitrogen, which is 14.007. Okay. So 3 times 12.011 is 36033. 7 times 1.008 is 7.056 grams. And then 1 times 1407 is 14.007 grams. We're going to add that up to get our total. 14.007 plus hydrogen grams plus carbon grams means our empirical formula mass is 57.096 grams. All right, now what the heck do we do with this? Well, okay, we need our ratio, right? We said at the very beginning of this, let's go back here, right? The molecular formula is a whole number multiple of the empirical formula. So what that means is what we're going to need to do to get our ratio is we're going to take the molar mass we were given and divide it by the empirical formula mass. This number needs to be greater than 1, and it should be a whole number. Okay, so let's do that here. If we have our molar mass we were given as 171 grams per mole, we just figured out our empirical formula mass is 57.096 grams per mole. And so if we divide those things, 171 divided by what we just figured out is 2.995, okay, which this nicely rounds to 3. So that means what? What does that mean? That means our molecular formula is 3 times our empirical formula, which means 3 times 3 is 9, so C9, H21, N3. That's our molecular formula. Okay. Hopefully that makes sense. Depending on what you're given, you might not have to do everything, right? You could be given the empirical formula and the molar mass and come up with the molecular formula by just doing this step of it. Or you could be given grams, you could be given percent, and you can work your way through it. So read the question and don't make it harder than it needs to be. Okay, last thing I want to get in this part is I want to talk to us about hydrates again, and we want to talk about now where do the hydrate formulas come from? Okay, if we remember, the hydrate is uh, a compound that has water bound in its crystal. Okay, so that means the water is part of the formula, and that it's bound in a specific ratio, and we can figure out what that ratio is. Okay, so in this experiment, and we used to do one of these, I don't really have time this semester to do one. Um, we would take a crucible like we did for the magnesium oxide experiment and put the hydrate in here. Okay, we'd use our Bunsen burner. I don't know why I'm deciding to doodle this, but I'm doodling this. Use our Bunsen burner and heat the crucible up. And we heat this thing enough so that all the water in the hydrate comes out. And it comes out as a gas. Okay. So if you get the mass of hydrate you put in there and you cool everything down and get the mass of anhydrous compound, remember anhydrous means without water, get the mass of the anhydrous compound when you're done, then you can figure out what the formula of the hydrate is. Okay, so here's our data. We have the mass of hydrate we started with, the mass of anhydrous we got at the end of the experiment. Okay, and we're also given some important molar masses. So this is iron 2 sulfate. So here's the molar mass of iron 2 sulfate, and here's the molar mass of water. Okay, with this data, we can figure out what the formula is. Remembering our formula should look like FeSO4 dot something H2O. We're going to figure out that N. The N here is the ratio of moles of water over moles of iron sulfate, iron 2 sulfate. Okay, so we need moles of water, we need moles of anhydrous iron 2 sulfate, and we can figure that out. Okay, so what do we want to do first? Let's do the iron sulfate first, since we have that. Anhydrous, this is our iron 2 sulfate. So 5 point, somebody is meowing in my ear, I'm sorry. 5.968 grams. Okay, and we're told 1 mole of this dude is 151.862 grams. Okay, this will give us moles of anhydrous iron 2 sulfate. 968 divided by 151.862 gives us 0.039299 moles. Okay, this is FeSO4. Okay, now let's do water. Okay, we don't have grams of water. We have grams of hydrate. Okay, remember the hydrate is the anhydrous compound with the water together. So to get water, we're going to have to subtract. Okay, so 10.9625 grams minus 5.968 grams is what? 10.9625 minus 5.968 is 4.9945 grams. This is grams of water because we did grams of hydrate minus grams of anhydrous. Okay. Now we need moles of water. Well, we have our grams of water, so we can figure that out. 4.9945 grams, right? And 1 mole of water is 18.02 grams. I gave us that. Remember, if you're not given the molar masses, you can always find them on the periodic table by adding everything up. Okay, so that many grams of water divided by 18.02 gives us 0.277164 moles of water. All right, So now we have moles of water, we have moles of iron 2 sulfate. Remember, we're looking for N in our formula. So we need moles of water divided by moles of iron 2 sulfate. So we have those things. N equals 0.277164 moles divided by 0.039299 moles. Okay, and I've got those numbers here. That's water divided by this guy is 7.05. I need one more digit. 3. Okay. 7.053. Again, this should be a whole number when you do this. So what we're going to do is round this to a whole number and use that to write our formula. So this rounds to 7, right? Because, 7.05, it's 7. Okay. If it's not exactly right, then we have to fudge it around a little bit here. So our formula then is FeSO4.7H2O. Okay. So remember, if you want to name this thing, then we just need the anhydrous compound name, which is iron 2 sulfate, and then heptahydrate to say that we have 7 water molecules attached to that. Okay. If you need anything, let me know. Have a good one, and I'll catch up with you later.